Alright friends, today we're going to talk about how to find the volume of prisms, and we're going to focus today on just the three basic kinds. That would be finding the volume of a cube, a rectangular prism, and a triangular prism. So I would like to start out with just talking about vocabulary words that actually do mean volume. So when we come across some of these problems later on, when we're reading word problems, which I know you people love, you'll actually know, hey, this word actually means this is going to be a volume problem. So here are some volume words that can help you know, hey, this problem I'm reading right here, I need to do a volume. So we'll start out with how much does it take to fill it up? How much will it hold? How much does it contain? What is its capacity? Some type of unit that's in cubic units, like cubic centimeters, cubic inches, cubic feet. So some type of cubic unit of some kind, okay? And again, we'll talk about why that is in a second when we talk about how we're actually going to use the formula and use the parts to get it. So fill, hold, contain, capacity, cubic units, and things of that nature. That's going to be talking about how much space is inside the item. So space inside, or you can write inside space if you want to do it like that. Okay. Alright, so let's start out first with our little cube. Okay, could call it a square prism if you want to, of course, because it's made up of all squares. So I'll do a little drawing here. So we've got our cube, and of course a cube is made up of 6 squares. Okay, and each one of those squares is exactly the same. So it's got 6 faces. That'll come into play more when we talk about surface area lessons coming up here in the next week or so. But let's just say the only measurement you know is that one side is 9 inches. Okay? So you've got to find the base area of the square prism or cube, whatever you want to call it, and then you take the base area and you multiply it by the height. Alright, so that is your basic volume formula for any figure. Okay, it doesn't matter if it's a cube, a rectangular prism, a triangular prism. We're going to be talking about pyramids later and cylinders. They're all the same. If you can find the area of the base of whatever it is, then you take the area of the base and multiply it by the height of that particular figure, then you're going to find the volume of it. So it's simple. You may see it written like this, where it's just V and there's a capital B, H. Okay, so that capital B that you see there stands for base area. So of course the base in this is a square, so you would have to do 9 times 9, get the area of that square, and then you'd multiply it by the height, which is also going to be 9 because all the sides are the same. So the basic volume formula is of course side times side times side for a cube, or for a square prism if you want to call it that. Short version would be volume equals S to the 3rd power. Okay, side times side times side. So if you don't have a calculator with an exponent button, you're going to be doing 9 times 9 times 9, or if you want to write it with the exponent, of course that would be 9 to the 3rd power. So of course on our little friend here, the blue TI-73, okay, it's got this little up arrow that's right there above the B/C button. Now if you don't know how to, if you don't have a blue calculator at home and you can't look one up online, you may just have to do 9 times 9 times 9. But on here I'm going to do 9, and I'm going to raise that to the 3rd power. So if I slide it over, you might be able to see it better. Okay, so 9, and then I'm raising that up to the 3rd power. And of course that would give me 729. If you have to do it out long method, you're just doing 9 times 9 times 9, which also gives you 729. So the volume of this cube would be 729. And how many things did we multiply together? Well, we multiplied 3 things together, side times side times side. So that's why it's going to be to the 3rd power, or otherwise known as cube. So 729 inches cubed. Okay, make sure you're putting the exponent out here after you write your unit. So again, 9 times 9 gives you the area of the base, and then that of course is 81. 81 times 9 gives you 729. And that tells you how much space is in there, how many cubic inches it holds, contains. You know, if you had little cubes, you could fill it up. It'd take 729 little inch cubes to fill it up. Alright, so side times side times side is our cube volume formula. Alright, let's move on to the next one. And I'll come down here and draw us a little rectangular prism. So you can think about your cereal box, okay? Maybe like Lucky Charms, maybe like Trix, or maybe like Cinnamon Toast Crunch. That's one of my new favorites. I like Cinnamon Toast Crunch. I hadn't ever had it very much, but I have grown to like it a lot here lately. But every one of those cereal boxes, of course, is a rectangular prism. So again, we can dot that in back there to make it a 3D shape. Okay. Now, same kind of thing here. You want to find the area of the base. Okay, so the basic volume formula again, I'm just going to talk about it as base area. Okay, and then whenever you find the area of the base, you just multiply that by the height of the whole thing, and you got it. Okay, so down here, of course, we've got a rectangle. So you know, if we were using one of those cereal boxes and we measured it, you know, basically this is 15 centimeters this way. Then of course it's a little bit thinner on the sides because that's where like the nutrition information and stuff is, and that's basically about 7 centimeters, and then it's about 20 centimeters tall. Okay, so in this, of course, since it's a rectangle, you know, to get the area of a rectangle, that would be the length times width part. Okay, so the 15 is your length, 7 is your width, and of course 20 is the height. So that just means you would go back and use the old length times width times height formula, which would be 15 times 7 to give you the area of the base, which of course would be that little rectangle down there. And then once you find the area of that, you just multiply it by the height of the whole thing, which we know is 20 over there. And that would give you how many cubic centimeters it's going to be. So again, we can go back and take our calculator, and we're going to do 15 times 7 times 20. Okay, 15 times 7 is the area of the base, and you just go ahead and multiply it by 20, which is the height, and that gives us 2,100. So that's 2,100 centimeters cubed. Okay, again, we multiplied 3 things together. The length and width give us the area of the base, multiply it by 20 for the height. So since we multiplied 3 things together, that means it's centimeters cubed. Alright, that's where your cubic units are coming from that we talked about up in number 1. Alright, so now we've got the cube. Now we've got the rectangular prism. And that brings us to our other topic for today. That would be the one that's the triangular prism. Okie dokie. So triangular prisms, of course, have triangle bases. So we'll start out by drawing a triangle. This is going to be a right triangle. And we'll put the little square right there in the corner so you know that's the right angle. Okay. Then I'm going to come down and drop the sides down. I'm just going to scoot it up so we can kind of get some of that other stuff off the screen a little bit. Okay. So we're going to drop this middle part down. It's going to be the longest one. These other two are going to be a little bit shorter. Okay. And again, if you want to dot it in, kind of give it that 3D effect. Okay, you can probably dot your little right angle square in there too. Alright, so if you compare that, okay, to what we had up here in the third one, if you just take and, you know, cut that either here or there, a triangular prism, okay, we'll make sure I write this on this triangular prism since we've come down here. Alright, a triangle is of course half of a rectangle. So a triangular prism is half of a rectangular prism. So therefore, if you're good at doing rectangular prisms, like you did back on number 3, you're going to be really good at doing triangular prisms because all you have to do is take half of it. So I'm going to show you a couple different formulas before I write any of the numbers on there, okay? So just remember that if you're trying to find the area of a triangle, okay, if that was all that was there and you're just trying to find the area of the triangle, you want to use the parts that touch the right angle for the base and height of the triangle. So you'd want to use this side and you'd want to use this side. So if there was a number over here, okay, you would not want to use that when you're doing the volume. Now when we come back and do surface area later on, you will want to use that number, but for what we're doing today, you don't need that number. So you would do base times height divided by 2 to get the area of the triangle, either here or there. And then you'd have to take and multiply it by the height of the whole thing. So that's one way you can write it, okay? So that's giving you the base area, which is the area of the base, which is the triangle. Then you multiply it by the height of the whole prism. Or you can write it this way if you want to. If you want to tie it back into what we did up here on the rectangular one, you would do length times width times height and divide it by 2. So you can see how it kind of ties in to what we did on the rectangular prism. So I'm just going to give you all the numbers and talk about the ones that we need to use and the ones we don't need to use. So let's say down here we knew this was 8 inches. Alright, let's say over here we knew this was 10 inches. And then let's say let's go up here, let's say they gave us 12 inches as a number. And let's say they told us the height was 22 inches. Okay? So out of those numbers that you see there, okay, you need to use the 8 because it's touching the right angle. You need to use the 12 because it's touching the right angle. So those two numbers are actually the base and height of the triangle. And then you're also going to need the 22 because it's the height of the whole prism. However, you don't need the 12 for this particular type of problem, okay, because that is not needed to get the volume. So we can do it this way. We can do 8 times 10 divided by 2, and then take that answer, which would give you the area of that triangle, and then you multiply it by the height of the whole thing, which is 22. And we'll just go ahead and do that one separate. So 8 times 10, of course, y'all know 8 times 10 is 80, and half of 80 is 40. So basically you're doing 40, which is the area of that triangle, times 22, which is the height. And 40 times 22, if you need to use your calculator, flip back some. 40 times 22 would give you 880. So that is 880 inches cubed. Again, we multiplied three things together, okay? The base and height of the triangle, and then the height of the whole prism. So 1, 2, 3. That's why it's to the third power, why it's cubed. If we do it over here on the other one, okay? If you do it like you normally would, you'd say, okay, well, the length is 10, the width is 8, the height's 22, so length times width times height would be 10 times 8 times 22, and then you take and divide it by 2. So 10 times 8 times 22, 10 times 8 times 22 would be 1760. And then if you take the 1760 and divide it by 2, that puts you down to 880. Okay? So either of those ways is fine. You can find the area of the triangle by doing base times height and dividing it by 2. And then when you find the area of the triangle, multiply it by the height of the whole prism. Or you can just do, like you did on the previous problem, length times width times height. And then since it's half of a rectangular prism, you just take that answer like we did here and divide it by 2. And I think I wrote that wrong, didn't I? That's supposed to be a 0. Okay. So 880 there, 880 there. All right. If you need to watch this again, feel free to go back and rewind it, watch it over, whatever you need to do. Hope this helps you as you do your assignments for the volume of prisms, and we'll see you next time.